Now we need to determine the area enclosed between the line y equals 2x plus 3 and the curve y equals x squared. Now you could draw these out, and there's no harm to do it as an exercise, but by far the handiest way to figure out, we need to figure out, here's our plane, we're going to have a line somewhere, and y equals x squared, right? That's a quadratic with not much behind it here, but it's going to be a happy face because that's a positive coefficient 1 really sitting in front of the x squared. So it's going to be sitting over it somehow like that. So they're going to be crossing over each other or intersecting each other somewhere. And their heights or their y values will be equal where they intersect. So the handiest way is just to do some algebra and just set x squared equal to 2x plus 3 and solve for x. And looking at this, we're expecting to get two values of x to solve this. So then it's just a bit of algebra here. And what I'm going to do is bring everything over to this side. So my first move is I'm going to subtract 2x from both sides. Right, so 2x disappears from the right, and on the left I end up with x squared minus 2x equals 3. So I've subtracted it from both sides, kept the balance, kept the equality. Now I'm going to do the same with the 3. I want to bring the 3 over. So I'm going to subtract 3 from the right, and I'll do the same from the left. And on the left then I'll have x squared minus 2x minus 3 equals 0, because 3 minus 3 is 0. And now I can solve this for 0. So solving this for 0, first of all we can try and factor it. And because it's going to be coordinates on a graph, I don't think we'll need to go for the minus b formula. So we should be able to factor it, break it apart somehow. So we'll have x squared, say minus 3x plus 1x minus 3 equals 0, right? So minus 3x plus 1x comes to minus 2x, and minus 3 times plus 1 gives us minus 3. This line here is equivalent to that line, but it just it suits us in our step for factoring. So I can, out from the first two terms, I can have x times x and minus 3 here, and I can have plus 1 out, taking the plus 1 out, and I have x minus 3 here. So the goal is to get these two brackets the same. And now I can go on further. X plus 1 times x minus 3 equals 0. This is just a top quadratic drawn, written in a different way. So just like this, because now we can say x plus 1 equals 0 or x minus 3 equals 0. So adding 1 or subtracting 1 from both sides here, we get x equals minus 1 or x equals 3. So these are our two values for x, which will be somewhere here and here along the x-axis, right? That's our x-axis. So to find the y values to go with them, we can go back and stick them into one of the original equations. So we could take y equals 2x plus 3 and stick in x equals minus 1 in here. Sub in minus 1, so y equals 2 times minus 1 plus 3, y equals minus 2 plus 3, y equals 1 when x is minus 1. So that gives us the point minus 1 comma 1. And do a similar process for x equals 3. We'll bang that into the same equation. So this time y will be different. Y will equal 2 times 3 plus 3, which is going to be 2 3s are 6, plus 3 equals 9. So when x is 3, y will be 9. So these 2 points, I'm just going to outline them in green, right? That point and that point, these are the points of intersection of our line y equals 2x plus 3. That's going to be a straight line, right? Because there's x is just the power of 1. And here we have a curve. And these are the points of intersection. Anyway, I suppose we didn't really need the y values, but it's nice to get them, because these x values will form our limits of integration. We'll be integrating we'll be integrating between -1 and 3, because to get the area between them, we'll be getting the area below this line and these limits, right? This will be -1 and this will be 3, and the other guy will be going like this, and we'll be subtracting the area below the curve, and that'll leave us with the area between the straight line and the curve. I can show you that. I have it here in Desmos somewhere, right? That's it in Desmos. That's y equals x squared there, in red. Here are our limits. The line x equals -1 shows the limits. Anyway, the limits are the points of intersection. Those lines just kind of heighten it, but we're looking for the area in between these two, in between the straight line and the curve. And we'll do that by getting the area beneath the line, applying those limits, subtracting the area beneath the curve using those limits. So now I'm going to clean off some of this stuff, right? We've been doing all this just to get our limits, which correspond to the intersection, the values of x at the intersections. Right, so we have 3 and -1 there. So, oops. What was that line again? Just going to write it in there. It was y equals 2x plus 3, right? Now, so our answer is going to be something like this. It's going to be, we're going to be integrating the straight line, and we're going to be subtracting the area like this guy here, right? And our limits is going to be 3 -1 and 3 and -1, and that's all we do. So we'll integrate this one. We'll get 2x squared over 2 plus 3x minus, and then we're going to integrate the second one. We're going to have to apply limits to this one, right? Stick our limits on the end there, and then the second one is going to be x cubed over 3, and there's our limits. So we're going to evaluate the two of these guys. I'll just tidy off a bit here. So the first bracket is going to develop into 2 brackets. Right, we're going to have something like this minus the second bracket. And then all of that is going to be minus, I could use a big curly bracket if you like, because I'm going to be subtracting then the outcome of applying the limits to the second integral. Just have to get a bit organized, right? So the first one is going to be 2 times 3x, 2 times x squared, 3, x will go in instead of 3, so we'll have 2 times, it's going to be 9 there, over 2, plus 3 times 3 is 9, minus, we're putting in a -1, -1 squared is 1, 2 over 2 is 1, so you'll have a 1, plus 3 times -1 will give us -3, and down here then we'll be going to 3 cubed, 3 cubed is going to be 3 multiplied by 3 times 27 divided by 3 will give us 9. minus, well, that's it. That's all we need there, right? I thought it was going to be much more tricky, right? And then in here we're going to have minus 1 cubed, which will become to minus 1 over 3, and we'll still have the minus out there, right? So that's 2 times 9 there. It's going to be 18. Just have to be careful here. 2 times 9 is 18. 18 over 2 is 9. 9 and 9 is 18. Minus 1 minus 3. 1 minus 3 is minus 2. Minus curly brackets, square bracket. We don't even need the bracket there. 9. Minus times minus a minus gives us a plus 1 over 3. So we get 18 plus 2, 20, minus 9 and 1, 20 minus 9 and 1/3. And we'll bang that into the calculator. We should be able to do it without the calculator, but anyway, minus 9. 0.3333. I get 10.66. So I get 10.66. You can go on all day with the 6's, or just throw in a 7 there. And that's the area between our straight line and the curve between those two limits. So I can switch back to Desmos and have a look at that. Does it look right? This one is not as easy to evaluate. What did we get? We got 10.611 units, right? Yeah, maybe. I think it's in the ballpark anyway. So that's it for that one.